In the previous video, we computed confidence intervals for the ERPs by utilizing the central limit theorem and approximating the average values of the voltage at each point in time as normally distributed. That's a completely reasonable approach. And because the normal distribution is so nicely behaved, it's relatively easy to compute these 95% confidence intervals. An alternative approach to generate confidence intervals is through a bootstrap procedure. Bootstrapping is a resampling method that allows us to estimate the sampling distribution of many different statistics. In this video, we'll introduce the notion of a bootstrap procedure and suggest how we might perform this bootstrapping. In doing so, we'll generate pseudo-random data from the observed EEG activity. We'll use the bootstrapping procedure to compute pointwise confidence intervals for the ERP. By pointwise, we mean that the confidence intervals are computed separately for each point in time, and we do not consider interactions across time. The prescription to implement the bootstrapping procedure consists of 4 steps. Step 1, we'll sample with replacement 1,000 trials of the EEG data from condition A. Step 2, average these 1,000 trials to create a resampled ERP. Step 3, repeat these 2 steps 3,000 times to generate a distribution of ERPs. Finally, step 4, for each time point, identify the value greater than 2.5% and greater than 97.5% of all 3,000 values. This range determines the 95% confidence interval of the ERP for the time point. In the next series of videos, we will consider each one of these steps in detail.